Alright, here we got another problem. 8 to the power of x minus 2 to the power of x, all divided by 6 to the power of x minus 3 to the power of x. And that equals 2. We're trying to find x here. Now, if you look at the equation relatively closely, you could see that you could use factoring to simplify the bases. Like, notice that like 8, 2, 6, 3 can be broken down into powers or products of 2 and 3. Like 8 can be 2 to the power 3 to the power x, you know, like this. Like 8 is equal to 2 to the power 3, and then the power of x you just kind of bring out there, and that 2 to the power x just stays out there. And then the 6 can be broken down into 2 times 3 to the power x. And then subtract it by 3 to the power x, right? And next we're going to want to factor the numerator and the denominator. Like in the numerator, there's a factor of 2x that's common along both like little bits. In the bottom, the denominator, we can factor out 3x. So we kind of just got like a it's an x. So we kind of just got this, and then in the numerator, 2 to the power x multiplying by 2 to the power x squared minus 1. Since we're left with like 3 power of x's, we kind of just take 1 away. In the denominator, we're going to factor out a 3 to the power x, and we're left with 2 to the power x minus 1, and that equals 2. And at this stage, you might like think you're stuck, but you're able to use the difference of squares. The numerator can be like split into this. Like since we have 2 to the power x squared minus 1, that's also equal to, don't mind that part, but 2 to the power x minus 1 and 2 to the power x plus 1. It looks confusing, but it's like if there was an x squared here, and then you just do x minus 1 and then x plus 1. It's the difference of squares. I don't know if I said that. And then we can just write the rest. And we could cancel out the 2 to the power x minus 1 from both the top and bottom. And that's providing that this can't equal 0. So x can't equal 0. That's for future reference. Since this equaling 0 would mean x is equaling 0. And we can't divide by 0. So we're left with this. 2 to the power x times, like parentheses, 2 to the power x plus 1, close parentheses, all over 3 to the power x equals 2. Now we could distribute the 2 to the power x in the numerator, I'll write over here. It'll be 4 to the power x plus 2 to the power x over 3 to the power x. I can just use the equal sign there. And then you can multiply both sides by 3 to the power x, like this side and this side. Two times 3 to the power x equals 4 to the power x plus 2 to the power x. Alright. Now then we could divide every term by 3 to the power x to group the exponential bases together. So we could kind of just, how do we work this? Like, this is still equivalent since we're divided by the same thing on both sides. I'll just do an arrow. It's not confusing. Okay, so the 3x's cancel out, and 2 is equal to, I guess we could have done it back here. It doesn't matter. Two is equal to the 4/3 to the power x plus 2/3 to the power x. Yeah, I totally could have done that back here. I kind of like just undid it and then did it and then did it. You know what I'm saying? Okay, and just kind of by like gazing, 2 answers appear. Like if we set x equal to 0, it's gonna be 1 plus 1, since anything to the power 0 is 1, unless it's like infinity or something weird sometimes. But this will equal 2, but remember x can't equal 0, so that's not gonna be one of them. Another one is just x equals 1, because 4/3 plus 2/3 equals 6/3, and that's 2. And well, that's gonna be the answer. You kind of just gotta look. I don't know how to do it any other way. Kind of just gotta look, guess, like put like numbers in of what x equals, and luckily it's 1, so it's kind of like either your first or second guess. But yeah, that's the only way I got the answer. So yeah, x is equal to 1. And you could plug it up here and check. 8, when x is equal to 1, they're all going to be the same. So 8 minus 2 is 6. 6 minus 3 is 3. 6 over 3 is 6/3. That's 2, and that is 2. So we got it.